you can take an unbalanced chemical equation representing a chemical reaction, and you can add or put stoichiometric coefficients in front of reactants and products, and you can balance it. So we're going to talk about this balancing process. Remember, when you balance it, now your chemical equation represents quantitative information. Now, the way I'm going to show you actually is by what we call trial and error. And the error part here, I will emphasize use a pencil. Just by nature, how we kind of go back and forth with changing stoichiometric coefficients. If you use a pen, it's going to look a little messier. So if you have a pencil handy, that's kind of a good thing to use for balancing for balancing equations. So these are just guidelines. Notice that, well, I've been talking about the big number. You could change the big number, okay, the big number, and I usually call it the big number, what those coefficients were to the left, to left. You can change those. Okay, you cannot change any subscripts. Do not change any subscripts, because if you change a subscript, then you're changing the reactant or product. Okay, so the big number to the left, that's to say the stoichiometric coefficients, stoich coefficients. So you change those till your little heart's desire. Let's see. So yeah, so you can change stoichiometric coefficients. Okay. You cannot change the subscripts. Thou shalt not make up new chemistry. Somebody else wrote that qualitative information down for you to go ahead and balance it. Another hint then, well, this isn't necessarily a hint, but like we saw in the examples, that big number to the left applies to the whole formula, okay? So stoichiometric coefficients apply to the entire formula that it's in front of. So let's take a look at this. Now this is unbalanced, to see what we need to do to balance it. Let's see. Go ahead and draw my famous brick wall. Go ahead and put irons, hydrogens, and oxygens. And I usually go ahead and write down how many there are with coefficients of 1 across the board. Okay, so let's see. If I go with, and I'm going to go ahead, if it's okay with you, I'm going to put green here next to where I can put a stoichiometric coefficient. So where those green dashes are, those dashes to the left of the formulas, that's where I can put a number. I cannot change the subscripts to make my irons, hydrogens, and oxygens to line up. You just can't do it, because then you're changing the qualitative information. So let's see, how many irons do I have over here? I just have 1. How many hydrogens do I have over here? I've got 2. How many oxygens? I've got 1, right? Over here on this side, how many irons do I have? Ooh, I've got 3. How many hydrogens do I have? Well, I've got 2. And how many oxygens do I have? I've got 4. So somehow I need to reconcile my 1, 2, 1 with my 3, 2, 4. So what I like to do is, and I think I have a rule coming up about this, is I would keep this guy, I would keep that to last, because it's pretty easy just to slap in a number there, okay? What looks maybe most complicated, start where it's most complicated. And I would leave this guy to the last too. Let's go ahead and, what I say, fix my oxygens. Because if you're going to fix your oxygens, okay, I've got 4 over here. Okay, how do I get 4 oxygens over here? Well, I can get 4 oxygens if in front of the H2O, if I go ahead and put a number 4 there. Now, anytime you change your stoichiometric coefficient, you have to update everything that was affected. So now, how many hydrogens do I have? Well, 4 times 2, dang, I've got 8. And how many oxygens do I have? Now I have my 4 oxygens. So that's good. Now my oxygens are set, but my hydrogens aren't. Okay, I've got 8 over here, and I need to up that 2 to an 8. How can I get 8 hydrogens over here on the product side? Well, I can get 8 hydrogens if I put don't know what color I'm using these days, if I put a number 4 in front of my H2, okay, now how many hydrogens do I have? The only thing I need to update, since I put a 4 there, is my hydrogens, and I have, dun dun dun, 8 hydrogens. So if I look at what's balanced, looks like my hydrogens are balanced, 8 and 8, and my oxygens are balanced. Okay, so what's not balanced are my irons. I've got 3 here, and I need 3 over here. So how do I get 3 irons over there? This is why I said leave this to last, because if I just slap a 3 in there, now I update my irons, now I've got 3. So by my account, 3, 8, and 4, 3, 8, and 4. So with coefficients of 3, 4, 1, and 4, okay, I balance it. Do you see how you kind of go back and forth? All right. Very good. 3, 4, 1, and 4. Is that what we said? I think so. Voila! And actually, what this does is kind of check that, yep, we have the same number of atoms of each type of element on either side of the reaction arrow. Pat yourselves on the back. Okay. So now this one, actually, this is one that I showed you when we kind of checked to see if it was balanced. I showed you this before. I would keep when I have a polyatomic ion, like sulfate and hydroxide, I would keep them as units in my tally. So if I'm gonna do that, then I'm just gonna have to tally up aluminums, sulfates, let's see, sodiums, and hydroxides. All right, does that make sense? I'll go ahead and put my charge when that's a +3. You wouldn't have to put the charges, but we know what they are, so why not? That's the tally. I'm going to put the same order over here. So we need to account for aluminums, sulfates, sodiums, Na pluses, and hydroxide, OH minuses, on both sides. So let's see what our starting tally is. How many aluminums do we have to start? 2. How many sulfates do we have to start? 3. How many sodiums do we have to start? I'm getting 1. How many hydroxides do we have to start? I'm getting 1 there. Okay, on the product side, how many aluminums do we have? I think we just have 1. How many sulfates do we have? We just have 1. Ooh, we're going to get some more of those, aren't we? How many sodiums do we have? 2. And then how many hydroxides do we have? Well, since it's in parentheses, it has a 3 out here, I'm liking 3 for that. You know, and everybody who balances is probably going to balance it a little bit different. So let's go ahead and, gosh, there's nothing that's, the one I saved back before, the Fe and the H2, I saved those coefficients till last. That's what we call something in its uncombined elemental form. I don't have anything in its uncombined elemental form, so I don't really know where to start. Let's start, if it's okay with you, by balancing our aluminums. Is that okay? We'll see where we go with this. It's been a while since I've done this one. So if I have 2 aluminums over here, how can I get 2 aluminums here? Well, if I put a coefficient, oh, I forgot to put my lines here. Let's go with purple lines. So where the purple lines are, that's where you can put a number. That's where stoichiometric coefficients go. If I put a stoichiometric coefficient of 2 here in front of our aluminum hydroxide, now I need to update the aluminum on the hydroxide. To me, if I update, I'm looking at this one. See, aluminums, now I have 2. And how many hydroxides do I have? I'm liking 6. Whoosh. Update that to 6. Well, our aluminums fell into place, and our hydroxides are way off now. Okay. How about our sulfates? Let's fix those next. Well, if I have 3 sulfates over here, okay, how can I get 3 sulfates over here? Well, I can get 3 sulfates if I put the number 3 in front of the Na2SO4. So now let's go ahead and update our NAs and our SO4s. So to me, I'm liking, let's see, how many NAs do we have now? 3 times 2, wow, we got 6 NAs, sodiums. How many sulfates do we have? 3 times 1, so that gave us our 3. Let's see how we're doing. Well, we got these two line up great, our aluminum sulfates, but these guys, sodiums and hydroxides, not so much. So now, do you kind of feel the going back and forth? That's very typical. So how am I going to get 6 sodiums over here on the reactant side? Well, if I put a 6 in front of my NaOH, now let's update our Na and our OHs. So I have 6 NAs, and how many OHs do I have? I've also got 6. Wow, what a wonderful thing! Doing that last step, actually now the sodiums and the hydroxides also match up. So we've got 2, 3, 6, 6 of everything, okay? So our coefficients were what? We end up with a set, what I call set of stoichiometric coefficients of 1, 6, 2, and 3. All right, I know it's really messy, but it doesn't have to be that messy. Okay, so that is the balanced equation. The balanced equation with that set of stoichiometric coefficients. We have the same number of aluminums, sulfates, sodiums, and hydroxides on either side of the reaction arrow. Now, if you wanted to break it down into, see, here's we go, there's our check. I think I have one more check here. Oh, I guess I didn't. But if you wanted to break the sulfate down into sulfur and oxygen, and the hydroxide down to oxygen and hydrogen, it would still balance. It's just kind of easy to think of them as a parcel if they're staying together as a unit like that, I think. Okay, so let's see. Yep. So one last slide. This actually, I refer to this when we had the Fe solid or the H2 gas. Okay, this is to say that the stoichiometric coefficients, I left those to last because they're easy it's easy to go ahead at the last minute make them balanced.